Hello everyone, welcome to another stream. How are you doing? How's things going? So, last stream we found out something amazing. We found out that we could how we could optimize our shader which bins draw commands per tile on the screen. So we're doing some UI rendering. We run a compute shader over the whole screen, and essentially every pixel needs to go over a list of draw commands and see if that draw command is inside, or it can be rendered for that pixel. And then if it can, then it gets the color that the draw command says it is, right? And obviously you can do gradients and texturing as well. So the way we sort of optimize it, because otherwise it's got to go over every single draw command. So the way we optimize it is we break it into tiles, right? These are 8x8 tiles, but we're doing 16x16 tiles now. And each tile has a list of draw commands, so it's a smaller list. So we had a problem where this shader was taking a very long time, the tile binning. It was taking 1.3 ms for this test scene here. But we managed to optimize it to bring it down to 0.5 ms for 16x16 tiles. And when we doubled the size of the tiles, it went down even further. So this means we should be able to make it even bigger, and that number gets even smaller. So one thing that I want to do is our UI render shader still takes a bit of time to do some complex stuff. So I think what I want to do right now is, because I know the answer on how to make the tile binning go really quick. So what I want to do is make this UI render. I want to take the lessons I've learned from the tile binning and see if I can apply it to this one part of the UI render. And so that's what we're going to start off with today. So, and then if that works, it should be like way better. So let's see, right now it's 1 ms, that's too high. We're not talking, it's because we've changed the tile size for the binning. So if we bring it back to 16, like we're going to solve this problem by having chunks and tiles, and obviously chunks are bigger than tiles. And we'll have a 2-tiered binning system, and that's how we're going to make it go like super quick. But we'll do that later. So right now we've got about 0.6 ms on this UI render, which is quite a bit. I think we can make it better. I think we make this better. So, right. So the optimization is we're going to preload data into LDS. So the first thing we're going to do is we're going to think about how this thing works. So basically this is the thing, right? We're going to have the whole screen and we're drawing TEST and the background. And we're duplicating that, so it's like a button we're simulating right over the whole screen. Now what happens is each of these essentially uploads an array of words. So you'd get like draw type ABB, right, followed by F32, no, followed by a matrix, right, which is 6 floats, right, that's 6 floats, followed by some of the command. This matrix is from screen to command space, and this is the size of the draw command in command space, so we can do some culling basically, or we can put into bins. What else? We've got then each shape, sorry, that goes at the start. Then you've got the shape, which then has like another matrix in it, so that's another 6 floats, right? Followed by a half size, and followed by a radius, right? This is what it takes to do an access line bounding box. So if we look at this, right, how many bytes is this? 6 bytes. Sorry, how many 4 bytes is this, right? How many words? Because that's what this is. This goes in like a words buffer, right? Like a words array. and then the GPU will read over this words array. So you have a draw command array as well, and this essentially just points to like, hey, it starts at index whatever and ends and has maybe how many words does it have, right? So it has 6, so there's 8 words there, plus another 1, 6, so that would be 15. 17, 18. So it's 18 words, right? That's just for a basic bounding box. But then you've got the this color where it's in the border, so it's actually doing a couple more, so it's like 20 words, right? Maybe around 20 words. And that's just for a standard thing. So what's happening here is in the shader, we're loading 20 words manually, when what we could do in theory is get the 32 threads which are running to actually load in that data all at once and then share it amongst all the threads. So we're going to be stealing some of this stuff here. Problem is the tile size is, so if we bring the tile size down to 8 by 8, we should really make this an 8 by 4 dispatch actually. Yeah, we need to figure out how to make this good. We need to figure out how do you land in a tile, because if you're taking it from the tile list, well, you could make it. Tiles have got to be dynamic in size, so really it's not a good idea. Hey Rohan. Work stealing techniques suggest so if quota of one thread is reached. Still that work. Yeah, I'm not sure because yeah, so yeah, it's something we discovered where if you preload into LDS, it can get faster. So if you're loading, yeah, so the problem is if you're loading, each thread is loading the same value, so it runs in lockstep, right? So where's a good example? Well, here, this one it loads 1 byte out of it, but every thread where it's running in lockstep is loading the same value. But it's faster if you preload it all. So it's as if like you're doing prefetching, right, into some cache, where the GPU maybe wasn't smart enough. That's the way that I'm thinking about it. Basically, rather than making it stall, go around, and complete its work, then stall again, go around, complete the work, stall again, go around, complete the work. Instead, what you're doing is you're saying stall once, now just go around and just grab it from a more local cache. So I think that is better because it's able to then switch out. I think that's the way it's working from my understanding at least. I'm not entirely sure. How's it going, Rohan? How have you been? So we have this. So the problem is we used to do it per tile, and that means we could just use the group index and then get the tile out. But what we have to do is know the tile size and how many dispatches you need to do to get there. So the tile size, if it's 16 by 16, yes, it has to be a direct multiple, which is fine. So if we go to where we dispatch this thing, UI render, we've got to make sure. Oh, it's using dispatch indirect, isn't it? Right. So just populate these guys, right? So you basically need to launch. So how many threads? How many to launch? How many? None waves to launch. The number of waves we need to launch is. So it's 32. Right, so if it's tile size, so we're not going to make this a constant in the soon. Hopefully this stream will be changing that. So that's how many pixels, and we've got this many. So that'll give us how many, right? So you've got 16 times 16 over 32, 8. Perfect. That's got to be directly divisible. So it launches 8 waves. So by launching 8 waves to fill a 16 by 16, let's just do that for now. Good. I was occupied with dense work for weeks. Finally breathing. Awesome. Good to hear. Yeah. Sounds pretty tough. Did you have to like work late and stuff like that? And work weekends? So when we pick this up here, you've got to take the dispatch group and then be able to figure out how many waves per... That's really a constant, but yeah. Waves per tile. That's really a better name for it, isn't it? Num waves per tile. So we take that. Then if we divide this by num waves per tile, so it will just compile to a shift right basically because it's a constant. So that'll get you your tile. That'll get you your tile. Good. But now you gotta figure out like the offset within the tile that you're rendering, right? So you then need to use, there's your tile coordinate. So then this gets you in pixel, in screen space, right? So then you need to offset it by whatever one you're at. So like if you're this many, like let's do some drawing. I think this is related to wave 32 and wave 64 joule units. Yeah, we're just doing wave 32. But yeah, we're not doing... Yeah. We're just going to stick with wave 32 because it's cross-platform. It works across NVIDIA, AMD, and Intel. They all support wave 32 mode. But yeah, I've learned a lot doing this shade. Although we figured out how to optimize heavily now. Like, it's taken time. Yeah, it's really interesting. So we've got divided into 8 pieces. 8 pieces. You want to say, so you divide it to 8. So it'd be strips, wouldn't it? That's 6, right? That's a 6-pack. Oh no. We don't have 6 packs because we program in C. We have 8 packs. Oh yeah. So that's what we want to divide it into, right? We've got a tile. We're going to put a wave like there, right? So you've got an 8x4, and you know your tile size across the X and Y, right? So what you have to do is you have to take this index, and we are just going to do this, right? And it should be fine. It'll make it like a Z anyway, which should be better. But yeah, let's try that. Obviously, as if the target's a bit wider, then it's going to go across and then wrap around. That's the way we'll do it. So Good morning, Sully. How's it going? Um, so to get the coordinate, we need to know what wave index we are, right? So you'll do like a wave index. So that is mod 32. Is that right? No, it's the remainder. Wait, is that right? That'll get you in it. Yeah, that'll get you the remainder, sorry. So that'll get you... No, 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 no. No, because it's directly divisible, isn't it? Sorry, it's being dumb. So what you want to know... Ah, this one. This is it. Sorry. Being completely dumb here. This one. Wave index. Bam. So this will be... Yep. So this will be 8 and it'll give you 0 to 7. Perfect. So now you just got to map it. So you've got your... So how many across do you need to go? And then how many up do you need to go? So you've got your wave size, which is 8 pixels across, and you've got 16. So yeah, modic remainder, yeah. Well, it's kind of like remainder. Yeah, one of them does sign. One of them is signed, and one of it is unsigned. You know, one of them. Yeah, one of them can go negative. The other one it stays positive. There's a difference there. Yeah. Um. So now we need to map this index to give us an offset from here. So we know the size of our thing. So it's the times by 8. So it's a sort of like a 8 times 4. Yeah, so you divide, so this is 16 pixels, right? You divide how many times does a wave fit into this? And you'll say, well, it fits, 2 times x going across and 4 times y. Then 4 times along the y. And then when you have your index, you're basically you're figuring out based on those numbers. Well, all we need is the x one, isn't it? So you need to know, so it's something like waves, num waves x. Num waves x would be UI tile size divided by 8. That'll give you 2. Then what you're doing is your offset. Yeah, manage your memory with malloc and free. Yeah, no, I think when people do the subs and stuff like that and raids, that's the little thing we have going. It's good. Num waves. So if you have so you have your index, you mod it against this, and then it gives you the remainder, and then the so wave offset is, so the x coordinate, let's ignore the x for now, but the y coordinate is, oh no, it's just this, right, isn't it? Divided by num-waves x. It's typical tile conversion stuff. Mod num-waves. Right, so that gets us that translates our 1D index into a two-dimensional one, where it's saying, 2 across, 3 down, right? So let's convert it into that. Now we can apply this offset to tile coordinate. What's this local index? Oh, plus the local, right. So this gets you, that gets you your tile in screen space, right. Tile, screen space. Tile position, screen space, which is that. And then this one will get you your wave position, screen space, so that you're adding to tile position, screen space, and wave offset. Then you're doing, I'll change this to pixel position screen space. That'll be the new name for that guy. Righty-o. So this one is going to be wave position plus this local dispatch, which is the local thread in the wave. Amazing. Right, so now we're in business. That is now transformed and shouldn't be using any of the, the wave size will be the same, but it's now tile size agnostic. Hey there, Scan. What's on my programming? We're programming a compute shader. Well, I've already programmed it, right? We're doing so we've got these shapes that we're drawing here using basically just compute shaders, right? We launched this a compute shader runs across the whole screen, and we've got a bunch of draw commands, and we essentially have, they're made up of sign distance fields, and you can join shapes together, you can color them in, you can do add and subtractions and make all these fancy shapes that you like. Even do some really crazy clipping stuff as well. Like this. We can clip to custom shapes. So we're just doing some really flexible UI renderer. So right now we're just trying to optimize the living crap out of it because it has been quite slow, but we've found out ways to make it quite fast, but I think I found out another way to make it even faster, so I'm just about to try that out, really. Yes, to run compute shaders. You play that vid when you get raids. Yeah, that's it. Yeah. Yeah, it's amazing. Yeah, we're working on a game without an engine. That's the big goal. What is the HTC compute macro? So basically it's a built-in, right? So on CPU it does nothing, but on the GPUs in our custom C compiler, it's this thing. And all this basically says is it's a compute shader. And these are the local dispatch. So this is saying, hey, in the local dispatch group, do 8 threads across and 4 threads down. Like, it's a, like, it just launches 32 threads, right? It's 8 times 4. Um, and if you know anything about compute shaders, there's basically like these things where there's like you can basically get the local index with inside that 8 by 4, right? And then when you launch a compute shader from the application side, you launch the number of groups, right? And the groups, you know, they that's a different index entirely. And then this is a combination of the group index times by your local times by your group dimensions, and then plus this dispatch local index, and that's your overall dispatch index. So it's kind of a bit complicated when you first understand it, then you realize how powerful it is when they split it up this way. It's this is all going through HCC. Yeah. Can we build / port what Jessica has built with Vulkan? It would be complete legend of a moment. What has Jessica built with Vulkan? I thought she used OpenGL, but yeah, the stuff she works on in OpenGL though is pretty insane. She just does some like crazy stuff in pixel shaders, from what I remember, and it's pretty impressive. One day I would hope to get that good right in shaders. Hey there, very much. What's the actual reason why they made it a 3D index instead of 1D? I have no idea why they made it a 3D index though. Yeah, I know why they've made dispatch groups, or whatever you want to call them, thread groups, and I know why they've done that, but I don't know why they've made it a 3D or 2D index. Probably because it just saved doing this maths all the time, right? Where you're translating a 1D to a 2D thing, all the time. And give you the option to do a flat one if you wanted, right? No, it's not to do with caching and locality, because if you do a imagine this is a 2 by 4 for some reason, your threads still dispatch like this. Wait, this is a terrible one. Imagine there's like an 8 by 8. That'll be good enough. It's not 8 by 8, but you can get what I mean. It still dispatches like this. Always. So it's still linear. So what people typically do if they want it to be cached better is they basically do the plotting of the threads themselves and get it to be like suitable for reading textures and that. But yeah, that's what they do. They do it manually. What happens if it's 31 by 4? It'd be weird as 4 waves of 32, 31. No, you get. Yeah, you should always make it a multiple. So what you'd do is you would actually get, if it's 31 by 4, you'll get 32 threads will go to the 31 in the first one of the next row, right? So imagine this is 31, then it will do this one as well, right? And then it'll do 31 again, and then do the next two. Like that's the way it'll work, because it's just a number given to you in compute. It's not anything special in hardware. Right, so fingers crossed, right? Hey, they're not so red. How you doing, man? Right, hopefully it doesn't crash. I've just refactored some GPU code, so fingers crossed, right? Okay, we didn't crash, but we got some. This is a good game. This makes my eyes go weird. Should we ship it? Yeah, I'm pretty sure there is no reason. Like from what I understand, I'm pretty sure there's no reason. Maybe someone understands it better than me, but I'm pretty sure. After all that I've gone and researched, there's been nothing. Um, I'll pay $1 on Steam, right? It needs to be a bit better, and need at least $2. Um, are we getting right? So you know what we can do, guys? Printf. Oh my god, printf. Yes. So we get 32 threads here. Right, what are we doing? So on that one, I want the Y. I want uh the local. Right, seems sensible. Oh yeah. Right. Take this bad boy for a spin. Oh no. Okay. Even better review, eh? Because fragments do all this stuff, right? Like fragments are a grid. Okay. So in a fragment shader, they have quads, right? But secretly that quad is ran in a compute shader on probably all of, like, technically it's just in a compute shader with some extra bells and whistles. So technically you've got your triangle um where it's like, let's do a little triangle. There we go. So that's a helper lane. These are all ran just about. And then what will happen is if you have another triangle, the these will be ran on the same compute unit, just next to each other or something. But yeah, I see what you're saying. Yeah, they would probably run. This one would be 0, 1, 2, 3, 4, 5, 6, 7, right? On the wave. The thread index on the wave. Yeah, they basically do stuff like that from what I know. Maybe it's different on each hardware, on different hardware, but from what I know about AMD. So if I natively write my 2D compute shader with a 2D works caches, yeah, so what you need to do, there's a thing called like a Morton Z curve. And then like, so you basically need to do this maths where you like take your index and map it out like this, right? And that gets you better cache efficiency when writing. There's even 3D versions of it, right? Yeah, that's what you need to do. You can chuck that in shame as well, you know? You call it the shame curve. The curve of shame. Awesome. Hey there, Nico. How you doing? Yeah, the 2x2 for the gradient. Yeah, the MIP. Yeah, MIP level thing. Yeah, that's right. Uh, rightio. Right, so we're able to see some data now. Right, so the wave offset is 0 for some reason. What? 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 Oh, wait a minute. Hold my beer. I gotta flatten this guy out. SV, dispatch local index. Good to see by the computer API. Yeah. Thing is very much, right? The more that I learn about this stuff with compute shaders and stuff, the more I'm just like, just give me that low level API, because I'm just like sitting in here optimizing the crap out for AMD, and it's just like, if we just had these like less BS high level Vulkan crap and just understood what that actually mapped to underneath and just programmed for that, just compute shaders, and they just gave us ways of just utilizing the hardware programmatically, it would just way better, way better. Like, there's so much BS you just have to learn to get to this level at the moment. It's not good. The latest been hours and hours research only to come to the conclusion that it's better not to use it. Yeah. Every time optimizing AD stuff, we should be paid. Paid RYT. Oh wait, what's that? Is that what does RYT mean? What does that mean? Right. It says your right. So my wave offset is basically nothing. So this is why we're getting the problem. What? Check my wave index then. Oh, am I right? Okay, got it. Gotcha. Yeah, we should be paid. Nah, it's cool. AMD's I really like AMD. Right, this is all zero for some reason. Yeah, I'm a big fan of AMD. I think they're good. Like, they give us access to to learn this stuff. There's open source shaders for lots of thing. Like they do so much to help people sort of learn this stuff. I just wish the other vendors were like this, and I wish AMD were obviously better and provided more of an open, gave us an API directly for their hardware or something. That would be cool. And then just every other vendor did it as well, because basically Vulkan and that is just a load of crap. Like, it's just really bad. Like, there's just so much extra stuff in there because they want it to run on every mobile GPU, and it just gets in the way of just getting work done. And also it's difficult to learn because you don't know what this thing maps to, and you're just sitting there thinking like, so this thing links with that thing, and like, why does it link with that thing? There's no like hot like solid thing you're sort of looking at. It's just all conceptual, you know. Can you do it right now? Do some wave intrinsics to test how the waves map into 2D space. Oh, that trust you. It'd be cool for me to see get a screenshot proof to people. Sure, I can literally just do it with this. I've got a wave index, right? No. Yeah, I've got this thing here. Yeah, like this thing here. I flattened it out. I can literally just like mod that and color it. Just give me 2 seconds. I just want to make sure this runs. Right. So got this wave index. Wait, I can literally just do it right now, right? Let's jam. Let's do another debug thing. So this is my debug tiles, if one. So we want to take this thing, yeah? So we'll color it based on this index. So I'll pass into that hue, the hue parameter here. This thing right here. Then but you can't tell. Oh, we want to make it increasingly red, don't we? We want to make it increasingly red. So we want to say divided by 32, yeah? Point F. 0. I've messed up my pixel position, haven't I? I'll do it in a second. I've got it here. Let me just fix this code and I'll enable it. That'll work. Let me just test this out first. So my wave index for some reason is wrong. Xmod num per tile. So this would be a group. It's not the group then. So how do you get how do you get the wave index? I'm using the wrong. It's not dispatch group. It is the group. Right, I'm doing the yeah. I should do the first couple of groups, isn't it? That's correct. Yeah, that's fine. Right, let's do the first n waves. So we want to do how many? We want to do the first 8. Oh, green index within the wave. Yeah, that's a good idea. We'll do that in a sec. Let me just get these numbers. So, right. So this one is wave index. See, the problem is my thing's tiled weird as well. Oh no, it should be fine. Don't worry. Ignore me. Don't. It won't apply. Right. So the second number is wave index. Right. So when the wave index is 2, your x offset is 1. That is a lie. Right, it's the wrong way around, isn't it? Of course. Because divide for the y round down. Right, so that's better. But, well, no, it's, yeah, oh, it's better. Right, so again, duplicates. We're getting a couple of 2s. No, we're not. Sorry, ignore me there, been done. So 3 makes sense, right? You got 0, 1, 2, 3. So it's 1, 1. Perfect. 1 makes sense, just 1 on the x. 2 makes sense, it's just 1 on the y. It's actually offset from the bottom left as well, so funny. 3 down, yep. That's the last one. Right, so I think this offset is fine. Oh, we didn't multiply it. That's the last thing. We didn't multiply this offset by the size of a wave. Whoopsie. And the winner is me. We're back in business, people. Right, so that test there for very much now. So very much wants this test. So you're saying you want the index within a wave to be green and red to be Oh no. And blue to be the wave index. Do you want red to be 0? Blue to be the wave index. Right. So if I'm launching this many waves, yeah, human dispatch group index. That's it. Should be it. Oh, you're colorblind. Yeah, that's like 10% of men, so I see why. Yeah, I typically like to do green and blue. Is it green and blue? Or is it red and blue? Yeah, red and blue, that's why I did instead. Sorry. That's obviously 0 then 1 right away. What am I doing? How big's the screen basically, right? So let's figure out how many waves we got on a screen. So we're doing divided by 4, 240. Uh, so it's not the perfect number, but it's basically there. Screen pixels. Why are they dancing, man? Are they dancing? What's going on? Let's introspect. Enhance. Actually, we can enhance this. Enhance. Zzz. I don't know how easy it is to tell, to be honest. It's bloody small, but we'll see, shall we? Not sure. I'm not sure. Karita. Right. So, what are we doing exactly? So we're saying like blue. So what was it again? So this index here is within the wave. Why is it going into blue then? Yeah, it's 8 by 4 blocks. I know that for sure. But why is it going into blue? Red, green, blue, right? So why is blue... Oh no, because blue's always on up here. Sorry. Okay, so the green is coming on. Gotcha. It's just storing into a texture. Right, so really if we take... Where's the... Oh my days, there's a big old thing I've got to kill. Give me a minute. Let me destroy this thing. Where's this thing gone? Right, I'll play the long game. I don't know where it's gone. I think I hit it a bit, but problem is it was flying by the light, so I had to. Right, what we're doing? Yeah, the other one's position, one's the color. Yeah, position and the color. So we flip the Y as well. Yeah, we flip the Y. So where it should be black, right? No, it won't be all up. Yeah, it'll be black down here. So here's where it's best, I guess. You know, let's get rid of this blue one. This blue one's annoying. It shouldn't exist. Because it's dancing all over the place. As well. Right, this one will give you your answer. Like, just straight up. Like, just take any portion of the screen. Look, here it is, right? So, your bottom left, right? See how it increases? So it goes horizontally, yeah? Oh, right. Yeah, you end up using my tile, isn't it? Yeah, I should have done that. Apologies. Yeah, that's what I was thinking about earlier, and then I convinced myself it wasn't doing that. I've got to do something with the... No, you know what? It's not going to work on this shader. But yeah, you've seen the answer, basically. It's not to do... We do something weird with a shader where our groups only launch across the x-axis. But yeah. Right. Okay, so we're trying to optimize this shader now. So why is the UI render 1 ms? Did we really make it that much slower? What did we do? We really made it that much slower by just changing those things? What? Right, let's undo all of this. Wait a minute. Are we launching too many threads now? Uh, 8 more. Right, let's undo all of this. Okay, put it back to there, yeah? Oh my days. We literally made it twice. Oh yeah, from 0.6 up to 1 ms. I thought it wasn't going to impact the performance at all. So instead let's change our local group size to be 16 by 16, right? So we make this a constant instead, and we'll call it something like UI render group. local X. Or render, like, you probably want to have like a minimum tile size, maybe. Tile size min. Probably that'll be 16. So if we do this instead, that will mean we can render multiple tiles or something. So that means we can do we call it cell size, maybe. Call it cell size, and the tile size is a cell is of a tile, something like that. Okay, right, something dumb like that. Waves per cell. Now it should fit evenly, so you shouldn't have to worry about doing the mapping, because it's going to be square, right? And it should be square, so your tile size just has to be a multiple of this cell size, perhaps. Yeah, so num cells per tile. So it'll be essentially like UI tile size divided by that. I guess just doing this was way too I don't know why it's adding that much. It might be because you're launching in smaller local group sizes. 8x4 isn't good enough. It should be 16x16. Yeah, so I think we should do something like this instead. So to achieve this, so to get your offset into there, we still might have to do something like this. It's square though. So it should just be mod 2. Right. That should be it. So put the cell size in the shared header. Right, we're back to where we were performance-wise. Great, so now we've got something that's scalable, I guess, where we can change the tile size. Okay, that's good. Right, so here's the performance optimization that we're trying to do. All right. So as I showed earlier, we've got the way we encode things in the array is we essentially have our draw commands, and it's like a nice little, like this is like a packed integer, by the way, these two. They're packed into like a single 32-bit integer. And the draw commands points into a words array, and the words array just holds all the data. So the problem is we're loading this data one U32 at a time, or one word at a time, right? So this has got 6 words, it's got 2 words, that's 1 more word, 6 words, 2 more words and 1 more word, right? So that's just to do this, and there's actually even more, right? With this color as well. So we can load them, rather than loading the same data across every thread, we're going to load different data across every thread and load it into LDS. All right, so we're going to do this, and we're going to preload. So let's just do a big number. Let's just do 128. I don't know if we're going to need that much, but let's just try that for now. So do U32, right? G, and then we'll just say like preloaded, we'll say draw command words, right? So we preload all the draw command words into there. That's the plan. So whenever we pick up our draw command, somewhere here, we pick up our draw, there's two, right? There's a clip, and then there's a draw command. Perfect. So this one here, this is where the magic happens. So we're going to do another for loop. So we've got 16 by 16 running. Shoot, which means it's not a wave. So there's two. Oh no. Yeah, that's why I wanted to make it a wave in the first place. So we might have to use those memory barriers. We need to sync LDS. Oh shoot. I don't think it's in here. No, it's in the atomics then, or something. Right. For this dispatch group, perfect. So memory barrier also waits for all threads. So we want to wait for all threads. Perfect. That's the one we want. So we're doing 16 by 16, right? So that fits like you know, eight waves running in lockstep but out of sync. So sorry, 8 waves running out of sync, but each wave runs in lockstep within itself, right? 32 threads. So we need to do a barrier to stop it here. Let them all go for. Let the first. Yeah, let the first one run, I think. Let's figure this one out. So we need to say thread index, or like word index equals 0. Word index less than let's call it W index, I guess. Words end. Right. So we're adding maybe 32. So we want to make sure that, I don't know, we could get all the threads going and doing their thing. Actually, we just need to know the size. So you're doing num threads equal cell size times cell size. Okay, so that's how many we're skipping by. So all we plan on doing is preloading that. So each thread is going to get. So is every thread going to be here though? That's the question, right? You would have gone out, you would have disabled sum here. So what you need to do is use the prefix sum to figure this out. So you need to know, hey, what thread am I? And then knowing what thread I am, will allow me to, yes, you need to do your wave prefix sum. So wave active prefix sum 1. This will give you each thread its own index from 0. And then what's the next thing you need to do? So you're saying word index plus thread index. Right, so num threads is actually wave active sum. And that gives you the same number across all threads. And because we add in 1, it will just give us the number of threads. So that's what we can skip by. So now each thread knows where it's writing the data. It also knows what data to load. So this would be, let's get this right, word index, that's the start index, plus the W index, right? That's the offset, right? Now, obviously, if your thread index, you can only do this if W index plus thread index is less than. Oh, I found the bugger. Let me get it. Gotcha. All gone. Taken care of. Right, so all we have to do then is just make sure that we don't allow the last sets of threads which go over to kind of ignore it. Let's say, sorry, to end up reading more data than we can. And ignore it basically. Right, so that preloads everything into LDS. To put the control barriers in because we've got more waves in a group. So hopefully that's fine. So let's just double check this, right? So you get the number of threads, get the local thread index, because it could be some inactive threads because some of the threads might return if they overhang the bounds of the screen or something. Oh, there's another one. Damn it. Right, I've just closed the window now because there's too many bugs. Yeah, these damn bugs. Right, so yeah, there could be inactive lanes already. So that's the reason why I've got to do these things. So give the thread index, start the word offset at 0. Go until we reach here. That's wrong. Right, that's wrong. So this should be start on word index because that's a range, right? Good. So then that would mean I've got to change this stuff. So you increment by number of threads. Good. You then say plus thread index. That's still good. Yep. This is wrong. So now this would be simply take word index plus thread index. Very nice. Then should have put it into a local. Yeah. Right, that's the index you're reading. So is that plus the thread. Put that into LDS there. Perfect. Now we've got the loading code. Now we've got to change everything. Luckily it's all inside here. So we can just search for it. So what we need to do is we now need to change our we now need to be able to do like a little load from LDS instead, right? So so what you're going to do now is your word index is now going to be equal to 0, right? And then you're just going to load from the words from LDS instead. So when you're loading just a word, it's not so bad. But the problem is you've got to load right, so should we see how good this is? And also how good my compiler is, right? Because we don't know. We might pull in a matrix as well, actually. There's another one that we missed. Right, so it should be loading in cached data now, hopefully. So let's see, GFX UI. Right, so see if that works. Right, so loading into LDS. So I'll load it from LDS. There we go. Cool. So where's our word index now? Right, so this word index. Right, and then word index. So word index end index is now going to be take away equal word index. So we reduce it, yeah? Pretty good. So each thread is going to go over the same index every time. So just load it from cached data, hopefully. So this is now going to be changed to record a macro. So this is going to be changed to gfxui LDS underscore. Then we'll go here, delete this, go to the next one. So we're going to do that until we've run out of things to load. Quite a few of these, but see how many little loads there is, and we're loading like at least 20 bytes of information, probably all the way up to, I don't know, could be quite a few, right? So we just got to be careful. So let's see if this works. What is this? Whoops, put that in the wrong place. What? Oh, U32. Radio. Okay, so we've just changed basically how the shader works on the hood, so if the stream crashes, you know why. But fingers crossed it hasn't. Right, so let's go. Right, so what we did is we just boosted the time up a little bit. That didn't help. So let's think about another reason then. Yeah, so I think there's two barriers. Let's remove the first barrier and see if that helps. That's made it even slower. Right. We're definitely loading from LDS, right? Has it changed my VGPR? Should we have a look at that? Alright, let's take a look at that. No, the VGPR is about the same. It's fine, it's about 39. It's not the issue. How much LDS have we got? 512, yeah, 128 times 4. Was that too much? Slow the LDS to 64. That's not changed anything. No, you got plenty of LDS. That's not right. Um, right. So if we undid this to compare it, right? Should we try this out? Yeah. So we increased the time there by, I don't know, 50 odd microseconds. So it actually wasn't a speed improvement. But let's just double check, right? Is it because of the control barrier? It might be, right? It should just give us glitchy graphics if we remove the control barrier. No, it's not. So putting into LDS and then running it is... Why is it slower? Why is it slower? We should need to put it before because that's going to glitch as well, right? Hey there, BO5K0. How you doing? Welcome to stream. I think for safety you'll need a control barrier here. So... It might be because of these wave intrinsics, right? If we were to do this differently, maybe we would these could be quite slow running them over and over again, maybe. If we were to use a local thread index. Let's do something a little bit silly, which is not going to be fully right, but it will yeah. Wait, it's 16 by 16, which is yeah, so wait, that might be right, isn't it? That might just... Oh no, but you've got inactive... Yeah. You've got inactive lanes though, this is the issue. So it's not going to be linear. Damn it. Oh my days. Right, we're back. Right, we are back. There we go. Alright. So yeah, we just got a GPU crash. That's all it was. What? It just deleted my whole file. You kidding me? Not that it matters. What is going on? Sorry, I've got the file. It's not a problem. I can just fish it back out. We did do the cell size thing though. Yeah, the problem is the driver just doesn't. It's pretty shit, basically. It doesn't robustly handle. So now I've just. See, it's fine. We was basically undoing the code anyway. But still, I did make it. Yeah, we only lost a tiny amount of work. Because luckily I did commit the code last night. Or on Sunday. Yeah, it's bloody weird. I don't know. I don't know what happened. Like, I basically forced shut my PC down, and it was like, oh, you know, just done a piece of work on me. So I decided to delete my shaders file. What a piece of work. Let's take a look at it. Wow. It doesn't actually exist. It literally deleted it. Oh, no, sorry, wait. Wrong one. Right, 0 bytes. I've had this problem before. 0 bytes. How scary is that? Yeah. Bastards. They didn't like my code. Right, let's restore it back. Was it git restore or something? Now I've got to remove that from my history because that can literally just destroy my nuts. You know? Could be doing something good here. Right. Anyway. Right, so back to the start of the stream. Let's just double check, make sure this all runs. Right, let's just quickly. We're dispatching too much then. So it's going to crash the GPU again if we run it. So, oh no, it's not. It's not going to crash. Good. Oh, they don't, do they? Interesting. Right. All right, we're back in business. Okay. So let's finish off what we was doing last stream then, the tile binning. So we're doing another layer, people. We're doing chunks. So we're doing chunk binning. So what we want to do is make chunks and tiles scalable based on the resolution. So we're going to make them variables instead. So we're going to be removing things, right? So we're going to make this, we'll have cell size, that'll still stay. But tile size is going away. And so is, oh, I thought I had someone else in here, but we don't. Good. So the plan is, right? The plan is to compute a tile size somewhere, based on the resolution. Probably after frames start, after we've resized the swap chain or something. I don't know. So what we'll do, I'll calculate down here. So what we want to do is compute a tile size. So a tile size is going to be, so we've got temp, width, and height. What else have we got to figure out? Well, we probably want to just say the tile size is probably a base of 16 multiplied by if they're 4K, maybe we make it 32, something like that. So I guess we'll just hard code that one. And then you've got the chunk size, right? Where you basically want to fit a good number of, I think we'll just hard code it. But the idea is they're coming in as like variables, and they're not constants. So that's what we're moving to. So we're adding a new guy. This one's going to be called chunk binning. So, if you've been following this before, we have done this in the past and we deleted it because I literally had a poor way of doing it in the compute shader, but now we figured out a good way to do it. So it will scale up to chunks. So we're just going to be sorting that one out. Chunk size. So tile chunk. Chunk dims XY, sure. Right, so we need to work out how many chunks. Tile dims, so that is div roundup. We're dividing the screen width by tile size, and then we're also doing the height. So it's how many tiles rounded up fit onto the screen. Then we need the same thing for chunk, like so. So these are going to be lovely. When you were, yeah, we're just using like a test. We're just using an ASCII font right now, Sully, just because it's easier to work with. I don't have to build a font cache and do all that stuff just yet. I can do it when I want to. It's just the easiest way, right? When I work on a large project, I don't use C-line because crashing system in the middle just wipes the local cache. I use Vim in most cases, nice. Yeah, Vim's pretty good, but I don't know why it didn't. I think I removed my swap files. But I thought I didn't remove my swap files. Yeah, there's something weird going on. What will the game be? We're going to decide that when we design the game. We're going to be doing some R&D first. We're just going to be doing some graphics R&D first and finding some cool new art style. Trying to make a unique art style that, well, unique as possible, that we can manage. That's the plan. So we need to make some new buffers, right? I need to be making chunk draw commands. Do I need a chunk list? I need chunk draw commands and that's it. I don't need a chunk list because that's dispatch indirect. Wait a minute. So you split into chunks, and then from the chunks, that's over the whole screen regardless. You could optimize it where you decide to get rid of whole chunks, and then you can do a dispatch indirect on that. Then you have a chunk list. But mm, um, hmm. So this would mean, yeah. Oh, do we need a? We'll just launch it full screen for now. I think that'd be best. Right. So chunk, draw commands. Right, so that's another number that's got to change. So we need to know how many draw commands per tile, per chunk. No, I think that can remain a constant. So we need chunk. So let's just say there's maybe 2048 max per chunk, I think. That should be good enough. Yep. So your tile size you probably, the minimum tile size would be the cell size, and the minimum what's the absolute minimum chunk? Right, so you probably need like a tile size min, and that's be your cell size, and the chunk size min will probably be cell size times by, so times by 8 maybe, we'll see. Okay, right, so now that we can use these constants, tile size min, chunk size min. That's the number of chunks. So we pre-allocate those buffers there, fantastic. Now the plan is to launch these shaders. So let's get these shaders going. So we need a new chunk binning tile. It takes input as draw command words, outputs chunk words. Sorry, chunk draw commands. Then we need to know how many chunks there are on the screen. We need to know the chunk size as well. And that's probably good enough. Can you imagine a Dwarf Fortress clone? Well, that's because we ain't got anything yet. I realize we're doing game without an engine, but I realize we're doing engine without a game instead of game without engine. That's right. That's right. Exactly. Yeah, we're trying to just build up the essentials to sort of like do some prototyping in. So we need a UI, and then we need some basic graphics rendering, right? Yeah, we're going to do a lot of shader code, so we'll be using HTC for, it's still going to be a drop in the water in terms of code because there's more CPU code, right? But we'll do quite a lot of GPU stuff though. So we're going to be using HTC a lot. Chunk. Chunk dims, chunk size. Something like that, yeah. Cool. Chunk binning. Fantastic. So we've got to find our tile binning shader. This is the one. Is it? No, it's not. This is the old one. This is the new one. Oh, it's good. This thing we optimized last time, and it was the missing puzzle piece to making the GPU UI binning go super fast. So let's just change that for a chunking system instead of tiles. So we just do this lovely rename. Chunks are just bigger tiles, right? That's all it is. Now this chunk list, where it's adding it onto there, that's a no-no. We don't do that. Shoot. So you've got the number of chunks you've got to write though. So what do? You write to the chunk commands, chunk this, chunk that. Perfect. Right, so you always write that out. That's just the number of commands in the chunk. You write that at the start of the array, which is good. So this UI chunk size has to be BC chunk size. Cool. So that should bin into the large chunks now. So the next shader to sort out would be the tile one now, right? So the tile one, we're still going to be dispatching across the whole screen. I'm not sure if we'll be able to save anything here. We shall see. But instead, this needs to take in the chunk commands instead, right? And we're filtering it down to two-layer system. Is your game engine going to be multi-threaded? If so, how are you going to design that? So I haven't done a very complicated like multi-threaded thing before, and I might have some fun and try and do like I haven't done like a job system before, basically. So I might just do something like that. Someone literally just asked that question on the Discord not long ago. So if you hop on the Discord, if you're interested in the links, that is, go to the Learning Resources tab. Someone literally just asked this: does anyone have resources around multi-threading and game engines? There's a couple of talks here I've listed that you can watch, basically. Then there's a link on Fibers and stuff that's more advanced. But yeah, that's what I might do, depending if the game needs it. If the game needs it, then if I can convince myself the game needs it, then we'll do it. Or maybe it just makes me think differently about how I structure the code or whatever. I'll probably convince myself, I'll find a way. I made a very simple job system in C++ recently. Nice. You made something simple in C++? Huh? You must be a wizard. No one makes something simple in C++, Sully. I think the most common design is having physics, AI, game logic in one thread and rendering in another. Yeah, that's the way you do it. That's the classical way you do it, right? You would separate them into, as many of them as you can into separate threads. Then you would, but that obviously doesn't scale across n threads. It scales across 4 fixed threads, right? But yeah, you the job system allows you to do scale across a variable amount of hardware, and that's where the fun is, but also the danger is, because it's variable and you have to test it. It's def simpler than the equivalent C code. Yeah, but that's the thing. It's like, sure, but maybe you can write a different way, which is even simpler, and it's compatible with the C way. Yeah, just because you can express something different in C++, this doesn't mean it's the right way to do it. Maybe. But there are sometimes where it's better in C++. Right, so the tile binning, tile size. This bugger needs to change. We need to upload that as well. We don't need a draw commands count anymore. We also then need to change chunk commands. Change the sync code. We then need a a tile size. Right. Pretty damn good. Sorry, tile size, that's what we need. We do need the chunk size actually as well because we do some debugging stuff. We'll have debug ways of displaying chunks and stuff, right? It's pretty fun. Cool, so with this, now we can start changing it. So we've got to make sure that when we're binning, we're reading from the correct, let's get this right. So like we do in the tile render, and render a whole tile, we need to basically get this code. And basically get this code. Something like this. So we've got the tile coordinate already, which means this code can actually go. We need to work out the chunk that you're loading from. So you need to work out a chunk index. So to get that, you need a chunk coordinate. And for that, you need to go from chunks to... So we should do a debug assert. I just realized. And make sure that chunk size tile size must be directly divisible something like that. So you must be able to fit the tiles directly into a chunk. The chunk coordinate then would just simply be, because it will truncate down. So you should be able to do div tile coord with BC chunk they're going towards, so how many tiles fit in a chunk? There's the song, Sully, did you hear it? Programming in C song, guys. Amazing. So that will get you, like, how many you need to divide? So yeah, it should be fine. So there's your chunk coordinate. So with the chunk coordinate, we can flatten it out and get ourselves a chunk index. So we need to then also get that in there as well. Damn Oh, the volume higher. Oh, damn it. Are you talking about the swap chain image from FIFO? Do we have it on FIFO or is that something else? So yeah, yeah, I'm not sure exactly what you mean. I'm in the wrong place. Right, this one. Yeah, there's two shaders, tile bin and shaders. One is commented out, obviously. Um, right, so this get us the chunk. Right. Let's get renaming. Rightio, people. So now I've got a start index into the chunk array. Sorry, the chunks draw commands array. So when we go to bin our tiles now, we've got the smaller list that is in the chunks. So we just got to do the for loop right is all. So right, chunk draw commands, load it in, get this guy. Right, let's see how much this compiles now. What I gotta be careful here. Let me just double check how the other one works. Right, so oh, it's this plus that. Whoops. What? Seriously? What was that? So, yes. Yeah, the start of your, yep. Excuse me. Yep. So what you have is some massive array of draw commands for all the chunks. There's pre-allocated subarrays for each chunk in there. This start index just gets you to the one for the chunk that you're in, and there's a local offset here. Right. I think that's good. So that was all that I remembered that we needed to do. Right, so this is probably going to not compile. Hey Robot, how you doing? Gotta go, it's bedtime. See you later, Rohan. Thank you for coming. Have a good sleep. I'll see you soon. Oh, that what's this called? Okay. Yeah, so for the swap chain, we've just chucked it in right now. There's things that we've literally just chucked in the Vulkan backend. And we don't really plan on changing the architecture probably at all, but there's obviously some options and stuff that we haven't really configured the best. And maybe we haven't handled um, setting up the hardware great on every possible configuration, but it should do fine. And if people come across issues that is stops them from running it on their machine, we'll change it. But yeah, that's basically the idea, right? It's good enough to start prototyping in, basically. How's it going, Robot? You been up to much? Yeah, I think I did FIFO because FIFO is always supported, but the other one always guaranteed to be supported by the spec. So I just did that without doing any checking, basically. It's just being super quick and sent out. That's all it is. Damn this thing. Right, I've got to change. What is this doing? Good. Right. Okay. Chances are this is going to crash, but we've got two binning systems now. We've got tiles and chunks. So we'll have to do another debug for the chunk system. Well, right, so if the stream crashes, I'll be back. But let's see. Right, it runs. Would you look at that? Right. This is super great because we're under 1 ms and we're seeing the benefits. Oh, yeah. Look at that. Who would have thought they would have seen the day of that quick binning? But yeah, it could get quicker. We just got to tweak some numbers. So let's see. Job interviews all week. So much stress. Oh my days. Yeah. I remember when I was looking at jobs. Firstly, you just like super, just like, you know, maybe you're like worried about saying the wrong thing and like, all sorts of things like that. But then plus, the amount of work you have to do to like research into the company, understand them, and being prepared and doing all sorts of things. It's literally like I don't know how people manage it while they're doing actually got another job. You know, it seems crazy. Is there a reason why you shouldn't use it for a game? Yes, because for a game, here's the reason. Milton time. Right. So you have a swap chain image, you have another swap chain image, right? And you have another swap chain image, for instance, right? Let's just say this too. So your game is rendering this one, and it's presenting this one. Oh no, let's say this. Let's say this 3. Yeah, let's say this 3. So your game is rendering this one. So it's really only for triple buffering, I think. Your game is rendering this one, and you're displaying this one, right? Then your game finishes rendering this one, and then it says, "Hey, this one's being displayed." Your frame finishes rendering this one, so then it puts it onto a little. It sort of says to it that it's ready, and then it goes onto a little queue, right? First in, first out. Okay. Wait, is that right? Yeah. So it goes into a little queue. So there it goes in at the start of the queue. Then your game decides to render this one, and it's so quick that VSync hasn't kicked in yet and decided to sort of like change this image to this one over here, right? It hasn't kicked in yet, and it's been that quick that it queues it up, right? Then the display wants the next image to swap to. So what it swaps to is this one here. But for a game, you've already rendered a better frame. So the frame that you actually want is this one, which was this one here, which you've just rendered, and that's why you want to use that. But yeah, there's different modes other than FIFO, and there's like this one called Mailbox that you basically want to use. Yeah, that's why you don't want FIFO, because you'll get the earlier frame. But you want this for a movie, right? You want it in linear order. But when you're playing a game, you want the latest frame, right? Okay, so we've got the performance increase that we hoped for. Should we tweak some numbers and see how much better we can get, or should we do the debug chunks? Let's debug the chunks. Chunks. Chunk coord. We don't have a chunk coord. Why don't we have a chunk coord? Well, because we need to do some division. And there we go. So what we can do is we can go to this definition. We can declare a new guy called chunks. See, the thing is, I want to make these compile time constants soon, because you might want to do this at runtime and just press buttons and see it all change. So we'll probably move this out very soon. to more runtimey stuff like little flags, and probably do compile time for like debugging options. So because it obviously makes the shaders slower, having the debug. Maybe we need to have debug shaders as well and compile it twice. You know, maybe. Or maybe not. I don't know. Can I find chunk size? What? It's right there. What are you talking about? Oh, UI render. Whoops, wrong one. My mistake. Do we need the chunk dims? Yeah, we didn't need the chunk. Right, so I could flatten it out and that gives you a better number. Yeah, why didn't I flatten it out? It's way better. Right, let's get the dims in there as well. Get the whole thing. Wait, how many is this? Let's count this up. 4, 8, 12, 16, 24, 8, 32. Right? We got 64, okay, that we need. So 36, 40, 44, 80. Sorry, 48 I mean. Yeah, then alright, let's count that again. 32. So that gets you 40 because that's 8 bytes, right? Add another 8 bytes, 48, add another 8 bytes, 56. 64. Shoot. This was here so it didn't inline. We might have to pack something because that'll go over 64 bytes. Oh yeah, the shader, the compiler literally just told us, right? No. $68, that's wrong. Where's the 2 bytes? I think it calculated that wrong. Yeah. That's a rat. Oh, I gotta pack these buggers. Damn these things. See, I don't really need the tile dims and that. It was just mainly better for debugging information. But, okay, we just won't have it then. We just can't have nice things. I was just hoping to make the debugging colors nicer, but it's fine. Yeah, I can pack it, but it's just effort to pack, is all, you know. Oh, I need the tile dims then, do I? Fine. Right. So in the shader... so this... What I'm saying is this debug tiles one I can make nicer. I can times this by BC tile dims.x plus, and that will give it a linear, that will flatten it out when it does the multiply rather than dinner. Yeah, just be better. Make it a linear number instead of two-dimensional number being times together. Right, so here's our tiles. It faces the problem here that we were talking about. But if I was to show the... Sorry, that's the chunks. Then here's the tiles. Yeah, that's so much better. That's so much better debug. By flattening that out. Damn it. Should we compress it then? We'll compress it. I want that. I want that. And we're talking AMD only. I've only got an AMD card, so I'm just going to be optimizing it for AMD, and then when we get into the future, we can optimize it for NVIDIA as well. But yeah, I do follow the AMD stuff more, because that's what I have. Hey, how you doing, Sockham? So these are our screen tiles, right? This is what we're binning into at the moment. So these have bins of 16 draw commands each. And then the chunks have 2048. Right, so there's 4x5 chunks. Right, so if we see the all right. So we need tile dims. What do we need from tile dims? We just need tile dims X. That's all we need. Perfect. So all we need to do then, so that's the compression. We just don't include the Y. Right, chunk. Righty O. Right, I just realized we need to, if we monkey around with the tile size, we need to change. If we monkey around with the tile size, we need to make sure we change the... Yeah, we need to make it tile size agnostic, this shader, because we did do it and then we lost the whole file because we had a GPU crash. Horrendous. Right, so... times by BC chunk dims plus that. Boom, that's me way better. So the colors are even nicer. So he thought. I don't know why they're not nicer. I don't know what I did, to be honest. I don't know what I did yet. But I shall find out. It's a high prime Sockham. It comes from the FNV hash. So what the high prime does is it makes each individual increment different. So 0, 1, and 2 are going to have a far different numbers. They're not going to be next to each other anymore. You got extreme delays? 10 seconds. Ooh. Wow, that's a lot. Yeah, that's the core part of hashing, basically, how they do such different numbers. Like, yeah, the FNV hash, basically, I just took it from there. Just took a high prime, but any high prime should be good enough. I just took one because I didn't have to search for primes, basically. Yeah, that should. I don't know why it doesn't work. Yeah, FNV hash is quite. So you should be getting something like this for the chunks. Yeah, so FNV hash is like nice and quick, but it does get collisions though. But it's good for small data, that's for sure. Is my chunk that wrong? What? The number's going to be that small, is it? So I think the division needs to be far smaller. Right, that's better. Right, so let's do like divide by 64. Right, let's divide by like 8. Maybe not, it's a bit, not much. 32. Right, now we're starting to seem horrible. So we'll do 128 again. Or is 256 enough? Right, that's good. That's a good number. Right, so now we're getting different colors for each of these. So these are obviously our chunks. So each one of these guys has 2048 room for 2048 draw commands, and that's what we're binning into. Right, so that's the debug chunks done. Nice. I like that a lot. So that's the chunking. What should we do about the chunking? Yeah, we should tweak some numbers now, isn't it? So, but before we tweak the numbers, we should go back to the cell size thing. What we need to do is we need to make sure this is agnostic, right? So this should be called pixel coord instead. Let's change all that. Thank you. That's the pixel coordinates. So we need to calculate this. So the problem is that we have cell size, right? So do 16 by 16. We've decided that this is the most efficient way to do the rendering at the moment. So if the tile size is bigger, so it's another one of these guys we need. Tile size and wait. Cell size. Tile size and cell size. Yeah. So the cell size is 16 by 16, but the tile size on like a 4K screen could be 32 by 32 or something, right? So we need to share that same bin of draw commands because the UI will be scaled accordingly. So you should just be able to share the same bucket of information. It's byte per byte. Yeah, that's true. You know what? I was saying that to someone. I think it was like a year ago. I was saying that same thing actually, and I was saying that maybe what you could do is you could take the FNV hash and do a SIMD version, which will obviously be different, but just sort of be inspired by it. But I don't know how to, like, I would have to look all the different metrics you would measure what makes a good hash function and see if you can make something comparable, because then you can make it fast, right? Are there cases where you go over 16 command limit per tile? Yes, so if you have 16 layers, basically in your UI, you'll go over, but we cap it. And we always do it in draw. How the hell did this bugger get in here? Oh, this is one I tried to kill earlier, but it's crawl away. Damn it. Right, let me It's dead. That thing just exploded. Oh. Yeah, so you go over the 16. Yeah, so effectively the way we do our UI anyway, when we issue our draws, they're issued from front to back. So if you overflow a tile, you'll just be overflowing the one at the back, which obviously could be bad if it's a big background. But yeah, I think if we ever encounter that, because we're running it specific for this game, we can just, you know, pick up on that and then just like change how many layers we've got on the UI because a 16 is kind of a lot. Um, but if I wanted to make it sort of generic, then I'm thinking we will turn to like a linked list system. So you'd still have 16 commands in, but you'd basically take the last one, index 15, and make that linked list to the next array of 16. So if it were to happen, you would just linked list and pay a cost of a linked list. Which is still fine, right? And that's the way I was going to do it, but I decided just to do it the simple way for now. We could just linked list it later. Well, you weren't talking to me about it, but I had similar thoughts. Yeah, yeah, I was speaking about said who, but yeah, it was I'm not seeing said who for a while. Yeah, but yeah, the link list would be good for that. Um, you just have to make sure you pre-allocate enough linked list entries to allocate. But yeah. Um, so we need to work out. So that gets you the tile coordinate. Then you need to work out your offset into the tile. Right. So this would be where your tile is. In screen space. So after your tile in screen space, you want to go to the cell in screen space. Right, position, whatever. So you want to get that. So that would then be what are we trying to achieve? So you need to get the number of tiles, number of cells in a tile. Num cells not num cells per tile. Let's just call it that for now, but I don't know if that's a good name. You're doing like, so BC tile size divided by UI cell size. So what you end up doing is saying divide that by that, and then you're taking the mod of that, and that'll get you your cell index, right? So you need a cell index. We did this earlier, right? But we just computer crashed, and it deleted our whole file. It was complete bonkers. Right, so that gets you the mod, gets you the cell index. So if the cell index, you'll be able to add an offset to the tile position, which should then be cell index mod num cell per tile. Right, cell index divided by num cell per tile. That turns it into a 2D coordinate from a 1D coordinate. Then you've got to multiply this result by how big are your cells. How big are your cells? Then your cell position. That should just be cell position and offset by the local dispatch. Your local thread index. And voila. We are good. So now we should be able to F around with that. And so yeah, fingers crossed it doesn't crash. What song again? Oh yeah, that one. Yeah, I knew it. So your game without engine will be 3D or 2D. We'll be doing 3D. So they're gonna try and find some unique-ish way of doing rendering in 3D. Ooh. So we won't be using triangles basically. Pure compute. Right, so if the stream crashes, it's because we've just changed code, but hopefully it doesn't. Right, we're good. Cool, so it didn't change any time, which is what we hoped. Okay. So now we can F around with so we could debug render the cells. Should we do a debug render of the cells then? Cell dims, maybe. So cells are the render units. Like they share the tile memory. Basically, the cells should be the same as the tiles. So you've got your cell position. What does that mean? If your cell size is... So your cell size has to be smaller. Wait, I don't know if that's agnostic. See, why do I need to turn this into that? Oh, I do, don't I? Because, yeah, I do. Right, okay, so how do I debug this cell? So you're basically doing the tile one divided by how many cells in a cells per tile. Yep. So that's the way you'll debug that one. Right, should we take that for a spin? I was expecting to see me cells. Right, it's because the thing it's called cell instead of cells. Plural. Right, so there's your cells, right? So let's go make the cells smaller, and let's just see how this looks. So it should be, so if we make the cells smaller, it will share the tile. Just 8 by 8. Right, that didn't work, did it? Does it still run properly, or is it just the debugging? Right, ship it. This is good old Stone Rebel. It's always either Stone Rebel or Nick Johnson. We will complete the game with these guys. Sign distance fields. Yep, we're using sign distance fields. We've got custom SDF renderer. So we have a super flexible. It's literally ridiculous. We have a super flexible, like, basically it's like a sign distance field virtual machine. We effectively have an API which allows us to basically construct a draw command which is made up of multiple shapes, and you can see this is an operation which says smooth subtract. So it basically subtracts this circle away from that circle and this circle away from that circle type of thing. and then it will color the final result in, and then you finish the draw command. So you basically compute something like this. We have one draw command which has an array of words. A word is a 32-bit integer, and this is equivalent of what goes in the stream. So you'll get in like some matrix for the command, a 2D matrix for the command, so you can do all these crazy transforms. You can do, this is the size of the draw command, so we can bin it per tile and chunk now. This is the shape that you've tried to draw here. This is the shapes matrix, how to transform the individual shape, because you can do that as well. And this is its half size, and this is its rounding radius. And then there's more stuff that goes on the end. So we basically like have a little virtual machine that has a little stack of distances that it will sort of push and pop on the end of the stack, and then at the end you'll be left with one distance, and that would be how you decide whether you're in or outside the shape, and then you can color it in or not. So we basically have that crazy system. So this is why we've tried to heavily optimize it, because it's super flexible, but we want to make it so that it's not crazy slow. We want to make it at least pretty good for basic stuff like whole screen of buttons. But if you want to do the more dynamic SDF animations and subtractions and things, you can still do that, but you just pay the cost, right? So yeah, it's gonna be super sweet. So yeah. Yeah, and the best thing is the API that you use to make it literally just puts it into buffers, and the GPU just takes it and uses it. So it's pretty nice. Like, super happy about it. This one makes Mickey Mouse, believe it or not. I'll show you. There you go, Mickey Mouse. You can also do it with clipping shapes as well. So you can SDF a clipping shape out of anything you like. And we just made Mickey Mouse. But it's kind of glazed over how... Right. So to color it, so you got the draw command. Right, this is a draw command. This thing. It comprises multiple shapes. We have a box around the draw command. And with that box, we can basically take our pixel coordinate and we can texture it. We can do a gradient, right? We can do a distance-based gradient if we wanted to, which is pretty amazing. We can do borders based on the sign distance field. We can do, yeah, like we've done here basically. So and you can also do multiple. See, this one's got a border and a texture, and it's blending the two together. But yeah. So we just basically leverage the bounding box of the command if you want a UV. So why worky? Because we didn't dispatch more, that's why. We're missing tiles. More tiles. Dispatch indirect. Needed more things now. Right, so that seems like it doesn't still work, but it's getting close. What? Nice. What about altering these shapes? Pure in code. So it's pure in code, but if I convince myself, we will probably make an editor using the UI, right? But we might not do that right away. Definitely later on, when I wanna do like a nice logo. We'll probably just make an editor and just do that, because the thing is, we are going to be building editors into this game. Like, I'm not going to go into too much on what I envision for the 3D graphics thing, but you know, we're going to be having an editor in the game. So it's not the only, you know, we're going to be building tools. So we'll be able to build like custom logos, maybe even animate it if it's going to, I've got to think about that. Like do animations and things in there. BMT, how you doing? Are you exciting things about the project? Yeah, man. Things are going good. We managed to optimize this super slow shader. Um, I've been trying to optimize it more today, and I thought I could take the learnings from the other shader and apply it to the one that renders the individual tiles, and turns out it didn't translate. So yeah, and then the GPU crashed, and then Vim saves my file while the computer shut down, and then it decided to make the file 0 bytes. So I basically restarted from the beginning of the stream again. It was one of them, but we didn't lose too much work. We just lost this thing that we'll rewrite again. Hey there, J-Tai, how you doing? I was thinking about that, some kind of SVG to SDF conversion. Decompose vectors into convex SDFs somehow. Yeah, I don't know about SVG though. But yeah, basically it will be some scalar vector graphics or scalable vector graphics. But yeah, it is possible to do that and have an editor for it. Like with this system, I just got to build the editor now. And the API is pretty simple. We can literally serialize it out to a bunch of commands and then just like load it back in and just literally, you know, run the API again. It's pretty easy. Oh yeah, Vim, NeoVim, yeah. Hmm. Um, why are you no worky? Right. We've launched more. So you've made your tile size less. It's now 8. This one is 16 or whatever, right? Is that right? Yeah. So you're now going to make this one 8, this cell size 8, just for testing purposes. So this will give you 2. You're launching 2 per. Right. Square it. That's the problem. So the issue then is this. Hey, was it wrong when we did it before? No, it wasn't. No, it's fine. Because it used to be 2-dimensional or something. I forgot now. No, maybe it was wrong. Yeah, I think it was wrong because we didn't test it out before. So you definitely need to square it. So you square it. Because then there's actually 4, right? Okay. This, yep. Well, I don't know. Leave that in the comment. Right, ship it. Somehow it's quicker, but I don't know why. Alright, let's just run through this. No, it should be the width. Yes, that's the number. So one is num cell x. Yeah, num cell across an axis. Then you have num cell, right. Right, maths. Completed, mate. So this one wants number of cells in a tile, so that's 4. Then these guys need the across an axis. Magic. Right. So that's actually rendered it quicker apparently, but yeah, I don't know why. 8 by 8, it shouldn't have done. But yeah, so let's play around with some other numbers now. So I want to try and make that binning quicker, right? So based on what we've got chunk binning now, which is 0.08. So that's 87 microseconds, right? So bearing in mind, our baseline shader is the clear, right? It's 0.05. Yes, it's 50 microseconds to clear the whole screen. So this is our baseline for a whole UI render. Like, how close can we get to that, basically, given all of this, right? So in total, we're looking about 0.79, sorry, 7.5. So 750 microseconds. So that's quite a bit. But yeah, maybe so let's try and make this binning less. This one isn't good. This one is probably not going to get any better, but let's just play around with these binning numbers for a bit. Just get optimal for this resolution. And then we'll, yeah. And then we'll, maybe we'll look into this one. I don't know. Okay, so if we say, let's go to the other. Let's remove that. That was just me doing some. Right. That's Mickey Mouse. We don't want Mickey Mouse. Where's the this one? There we go. Shoot, it's not even rendering. It's not even rendering? At all? Uh-oh. We put all this in here and it's not even rendering. Did we overflow a buffer? We couldn't have overflown a buffer, could we? No, it's not 1920, it's smaller, it's 1280 by 960. So yeah, quite a few less pixels to be honest. Yeah. So that's not even rendering. But what does the other one render? Right, or did I just mess it up? And why does that one not render now that I've put that there? What did I do? Did we have a half-finished draw command rendering or not rendering? It's fine, you can use DLSLs for the final game. No. Yeah, that's what most games do nowadays, isn't it? They're just like, high resolution's too hard, let's just upscale and cheat our way. Yeah, we got FSR on AMD. That's it. None of that fancy DLSS. None of that. None of that. See, oh my days, Nvidia. Like they want to just sell their tensor cores basically and make more black box machines. You know, not a fan of those black box machines. Like it's moving GPUs more into, you know, hey, use Vulkan plus this complicated API we've made even more on top of it, right? Like we want less complicated API. We just want to be able to run code on the GPU, you know? And we're more in the other direction. Is yeah. Like you think you're getting somewhere, and then they do stuff like that. I'm not sure if you've seen the new 3.5 DLSS thingy, right? It's yeah, these people. Um, why you know worky? What is going on? This one runs, but this one doesn't. It's because of this, right? It's because of right. I think I can debug why. These are all complex renders. Right, it's clamping off the. Ooh. Or no. This is what it is. It's simply because it's only one render. Yes, if we make 16 renders, it'll work, or whatever it is. If I go and do this this many times, it'll work. So there's a clamping issue with the binning or something. You need 32 of them or something. Let's wait for it. There's a better way to do 32, isn't there? Iterating floats. Oh yeah. There you go. It shows up. So clearly, it's something to that binning code. In the chunk binning. So it's something to do with the chunk binning. So we can check to see if we're launching this at all, really. Or launch. XY. Yes, you'll launch them all fine. The draw commands count should be like 1 or something, right? So, core abort. I've yet to put the 4090 through its paces really properly. I've been doing some CUDA cores on it, but I've got to start cooking it. Oh yeah. Yeah, they're pretty impressive cards. But they're also like, yeah. Like I do think the I do think what they did with the new DLSS was really good though. Is they made it work on old cards because they brought out DLSS 3 and they were like, no, it only runs on the 4090 or whatever, the new cards, right? Whereas they actually made it right. So there's 14 commands count. Good. So you can see that number now. So at least you can run that new DLSS on like all the RTX cards, I think. That's pretty nice. But yeah, that 4090 got all that energy, so you got to pump out some good renders on it, you know. And you gotta use your triple, you gotta use your like, your triple left and do all this stuff. Wahoo. But yeah. Yeah. So why the binning no worky? So you increment in 32s, right? Increment in 32s. So obviously the first the first 16 or whatever should go through here just fine. Fish your boy out. Take it from screen to command space. Check to see if it's inside the bounds of the half dimensions. If it is, bingo. Wave prefix sum, my friend. +1. Get the insert index. Chuck your boy in there. And jobs are good. All the threads that inserted, chuck it, increment this boy. Do the wave active max on there. That's a bit of a hack though. I don't know if we needed that. But maybe we did. Maybe I could have made that better. And avoid one less wave intrinsic. Because that probably doesn't help with the performance. Like doing all of this everywhere. CUDA's not that bad. Yeah, I heard it's actually like a really good environment. Like I heard it's like good to just do. Like it's probably better than doing what we're doing here with the. Well, okay. Than learning like to set up Vulkan and do dispatches that way is probably a lot nicer. You know, and using HLSL or GLSL or whatever, some different programming language. Whereas instead you can just write CUDA and just do it all basically. It's pretty cool. Alright, so this should be some number, right? So you know how we can tell? So you can't do this in GLSL, but you know, pretty amazing. So we'll just say, right, if SV dispatch so with the first thread, we're going to print. So we're going to print out this number. And we'll find out exactly what it is. It's that amazing. Right, so we're clearly getting numbers in the chunks. So this means, and they look sensible, right? Because it's just doing like a draw command. Yeah, it's just doing this, right? So if you split it into even chunks, you should surely just get. I don't know why one of them is getting 5. It literally must be overlapping like here, right? The chunk, something like that. Oh, there's the background. So we're doing stuff like this. Yeah. Okay. So these are looking like good numbers. So then it means it's definitely getting into the chunking system fine. But now it's about the tile binning is probably the issue. I think AMD has some way of taking CUDA and running it on AMD that they've done. I forgot what it was called though. They've done a new. Was it CUDA or something else? ROCm. Right, I wouldn't have guessed that. That didn't commit to memory. Yeah, okay, that converts CUDA. Yeah, okay. Yeah, I'm not sure how good, it's kind of newish, so I would be careful about it. I don't think it's that ready, but it might be. I've never used it. I remember it only came out like a year or two ago. Yeah. Um. Right, so what are we trying to figure out here? So this does the binning it as well. What is this? Oh, it's the wrong shader, that's why. Whoopsie. This is the one we're using. Right, so we should be binning in some tiles thingy. Right, let's see what we get. Absolutely nothing gets here. Nothing. Nothing reaches here. So if I were to remove this, we should see a bunch of zeros. Okay, there you go. Success. So, we're going to make this go and get us stuff. So, why in this case then is there less? So we should be reading... So instead we're going to be doing the chunk ones. So let's read this chunk command index. No. This one. Let's see how many we get here. Do we get... We don't even get a number here. So clearly what we're reading out is not right. Why is it not right? We're dispatching across the whole screen. So we don't need tile chord, all we need is... Hmm. So I feel like we're reading the wrong chunk coordinate. Like something fishy's going on with that. But no, if it was able to render a whole screen, right? So if it was able to read a whole screen, why is it failing if we don't do round it up to 32? Hey Joe Mega, how's it going? Been busy with Starfield after I got a new GPU. Oh, your 4090 died? Have you managed to send it back and get that sorted out? It was a burial, yeah, just like take out to the backyard and bury it, yeah. Yeah, sad. Hopefully you managed to get that sorted out, because that's expensive. Yeah, how's things been otherwise? You've been, how's work and things? How's the UK? Um, see, I feel like we should be getting... So you're getting a chunk. Yes. Hmm. So these are all zero? This just seems crazy to me. All zero. We're dispatching across the whole screen and they're all zero, even though... So we must not be reading from the right chunks then. So, okay, let's get the chunk X and Y into here. Chunk XY, so we're saying that chunk X, Y, right? Now, we also want to be able to say tol is in this one, right? So that would then be tol chord. Right, let's try this boy out. So only the first thread is going to do this in the group. So yes, one per tile has been printed out. Amazing. Right, so let's figure this one out. So your chunks. So you've got it's 5 by 4, isn't it? So the y coordinate is dead. Look at it. Indeed. Oh. We have had a bug the whole time with this binning code. We've been using XY and only loading from the top tiles. Shoot. This could have an impact on performance. Because of caching, but hopefully not. We'll see. Alright, let's have a catch up with Chute. It's in a box waiting for me to be collected by MSI support. Hopefully they can fix it because I bought it via Newegg and apparently they don't provide a warranty. No engine at all? You're not user. Is this a flex? Yes and yes. Yeah, it's mainly just because it's fun. This is what I like to do, you know. And I think that yeah, this is an art that shouldn't be forgotten, you know. They're notorious for trying to weasel out of the company. Yeah, different company warranties. Yeah, yeah. They, you know, you meant to have a. Yeah. They just send you to the company, isn't it? Yeah, Newegg, I've heard. I can say what two of my. I can say what two of my colleagues worked on Mortal Kombat 1. Nice. Oh, is that where you work? I didn't realize. Very cool. Oh no, you don't work there. You're maybe working as part of another studio that helps out, maybe. That's my guess. That's cool. Yeah, I know, right? There's so much information where you can't tell. And it's like finally, years later, you can tell. Like, I can't wait until years' time where I can tell you guys what I've been working on at work. But yeah, I can show it off. But anyway, until then. No, I'm not an Arch, I'm on Manjaro technically. But yeah, Arch based. Right. Yeah, code studio. Cool. Very cool. Alright, dispatch group X. So we only launch. No, 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 no. This is fine. XY. Dim's XY. What's going on? How the living what are you doing? Yeah, why is your Y 0? Why is the Y 0? What is going on? Oh no, okay, sorry, it's gone to 1. Sorry, I was just looking at the wrong information. Right, then when it goes up high enough. How many tiles fit in there again? It never goes high enough. Um, how many tiles do you have across the screen? I don't know, 30? Do you have 30 tiles? Right. So we're getting different chunk indices here. Um, do 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 do. So 2, 3. So you've got, was it 2, 5, 6 and yes, 2, 5, 6 and 16. So you fit, isn't it 16, right? Yeah. So you fit 16 tiles in, so that divided by 16 gets you 16. So it's that divided by 16. So, you know, if you do 41 divided by 16, that gets you 2, right? Round it down, good. Then 59 gets you 3 rounded down. So that's the right chunk index. We're getting the right chunk indices, right? So something is definitely fishy when we read out. So when we read out this count, it's wrong. Really wrong. So my chunk dim's not initialized. This could be it. Tile binning. They're initialized. Yeah, so you're getting. Let's print that as chunkdims.x. It would get. Should be only getting 5, right? Yeah, 5. So that's fine. But this number here is like not even gonna be anything sensible like ever. It's always 0. So let's read. Like we definitely store that, right? Are we setting the chunk dims? We are. Hmm. What is that? Chunk half dims in command space. Sure. Yep, that's fine. So why is this value 0 in the buffer? I guess we can look at the indices, and then the indices that write out, we can check them the other side. We've put sync code, right? Read write, read only. Alright, that's the next thing we're gonna do then, is we'll right, so put something here. So this one is the count. What do we want to get from here? We also want to get the start index as well, like where are we inserting this? And then we should be able to marry that up with the other side. So these are the numbers we're getting, right? These are the chunk. So we're always putting 4 in, 4096, right? So we should be able to take something like this, go down to the tile binning, and we should be able to look at this and say, hey, if this is equal to 4096 and it's the first thread, can you just say, tell me how much this number is? So you should only render that once, only be output once, right? A bunch of zeros, so we do hit that. So this number, are we passing in the wrong array? No, it's the right array. Okay, so we are narrowing down the problem a bit. So if I were to manually punch the number in, still 0. What the bleeding bleep is going on? We're literally punching the number in here. Here it is. Got a 4 in there. We threw it in there. So are we really submitting it? We must be. Alright, this is where we're storing it. You'll be the only thread submitting it there. Oh. Here's the problem. You only want the first thread to set it. Because there's 32 threads running here. So they should all be the same value, but you might... Yeah, they should be all the same value because you're doing a wave active max here. Well, yeah, maybe we should try and make this better, but yeah. Or there's a... Anyway, there might be a race condition or something, but I will write in the same value or something, right? So that's the problem. Oh yeah. Right, that was a bugger, but anyway, we fixed it. So, we're back in business. So we can now test this other scene out that we've got running. Wow. So the chunk binning obviously only takes this much because it's not that much is running. Then you've got this tile binning which takes this much. So it's basically negligible for very little rendering on the screen. Which is good. So okay. So now let's go back to the other one, which fills the whole screen with buttons. And let's tune the tiles a bit. Right, so here's our test scene, where it's just literally a bunch of buttons. You know, about 2,000 draw commands. So what we want to try and do is see if we can make these numbers less, and then we'll look into this if we've got time. So if we change the chunk size, so we'll say like to do calculate based on the screen resolution. You know, maybe when you hit nearly 4K, you just double it or something, right? Or maybe there's a smooth way to scale it. So if I up this to 512, does it change? So now what we've got to beat is 0.08. So that made it 0.09, so made it slower. So we don't do that, right? So it's still 128. So made it 0. Right, so apparently 256 was the sweet spot for binning that shader for this resolution. Wait, yeah, 256. So let's change the tile size. Maybe we just guessed the right numbers. Let's change it to 32. So this one we've got to beat is, well, that's not a good one to test actually. I've got to run it from the beginning again. Machines. So the number to beat for the tile bending is 0.05. Right, so we've made it quicker, but we've traded it performance for this. This got worse performance. But if we go down to 8, yeah, so this one up, and this one didn't get any better. So I guess 16 was a good number, or is a good number. Cell size of 8, that could probably be 16. Cell size of 8, how's that looking? Yeah, so it's slightly quicker on the render, so I guess we'll stick with that number. Right, so I think we can't really tune those numbers any better. The only thing we can tune is probably the binning code. But what I want to do is quickly... right, just in case we get GPU crashes when we're monkeying around, should we do some... let's commit this. Because we did just have a whole file delete for us. So we'll say this is like add chunking to UI renderer. All right, okay. Sweet. So that's a good addition. So that's made UI rendering a full screen like under a millisecond, which is, it's good enough for now. I was hoping to get better, but so let's monkey around and see if we get this number better. So right. So this UI render, can we reduce the VG PRs or something? You know what, might try and do. So we've got this. How many VGPRs we got, right? So we're using here it is. This is our shader. 38 VGPRs. So we're allocating 40. So hey, why do you use Vim tabs instead of buffers? I use both, but if I'm switching between tabs, they're basically next to each other. I need to keep about 3 open so I can just go one to the left, one to the right. Because buffers require you to sort of, you know, search, and it's a little bit more keystrokes, but I use both. So 40 VGPRs. You get 100, sorry, you get 1024 per compute unit on RDNA hardware. So if we make this directly divisible by that, since it's the only compute shader running, it should do better. Well, it might do better, right? We've reduced the number already, but I want to see if I can reduce it more. Now, something that I remembered is we did have this distance operand stack, and this goes into VGPRs because they're different per thread in a wave, right? So we've got 8 of these, that's 8 VGPRs. So let's move this into, let's literally take it and just move it. Oh no, we can't, can we? Because it go. You've got to do some fancy magic. Yeah, you'll reduce 8 VGPRs at least. You have to keep 1 around. Yeah. Let's just see if moving this up here can help with performance. And if it does, that's cool. But if it doesn't. So you need like a distance stack offset, right? How do you get that? Well, it's simply the flattened index divided by, so distance stack offset, this would be in a VGPR. Local X, local Y, what are we timesing it by? There's cell size, right? Then it's that divided by or is it that multiplied by the number of what are we doing? This one. So divided by 32 waves. So that will get you your, wait a minute. Yeah, that'll give you what wave you're part of in the thread group. And then times by that offset. Sweet. So there's your distance stack offset. So when you do your distance stack, it's just that plus that. Alright, fingers crossed this don't crash. Okay, right, so give that a go. So it's this times the number of, like, local groups you have. I don't know if this is going to be good. I really don't. How many divided by 32? Right. So fingers crossed this doesn't crash. Let's do a sync just in case. Right, so still running. I think that's quicker. It doesn't render the same though. So by moving it to LDS, see, I don't know why it doesn't render the same though. We've got to think about this. Let's check the shader stats though. We haven't reduced the amount of VGPRs down enough. But there's our LDS size. Is that enough? We'll see. Yeah, I was hoping to get it down to 32. But simply moving it into LDS has made it better. For some reason. Did it make it better? Let's just double check that. Right, let's try this. Yeah, it literally made it like made it 20% better, which is pretty good. I don't know why putting that in LDS. A different one per thread on, yeah, so let's put it all back. In the meanwhile, checking out new ID for Rust. A JetBrains one called Rust Rover. Oh. I thought people used the Rust extension for C-Line, but fair enough. Nice. I thought you'd be inside the Visual Studio side of things, like VS Code, but I don't know. Right. So, are you allocating too much or too little here? So each thread needs it. Each thread needs its own. So divide by 32 is not good. Alright, let's try that. It's still better. I don't know how much better. Was that less LDS? Okay, no, it's the same. It's the same. So cell size times cell size. Does it need to be multiplied by 32? It does, doesn't it? It does, doesn't it? And I'm scared about that number though. Oh, come on. It actually made it quicker allocating more LDS. How? How did it make that quicker? Allocating more LDS. Oh no, it made it way slower. Right. There's a 6 there. Right. Good, good, good. Right. Okay, that one better. Okay, good, good, good. Right, good to know. So, actually this might not work well. Because if each thread needs it, each thread in a wave across all the groups needs it. Yeah, so that's not a good idea then. That's not a good idea. Because the distance values are all going different. Right, so undo all that. Anything else we can chuck into LDS and see if it's better? So we've got 38 VGPRs. I want to try and bring it down to 32 VGPRs. We're saving a few things for the... What are we saving for the end? We're saving... So you could use final... You could chuck final color. That's 4 VGPRs. You modify it when you apply the coloring. For each command though. So if you chuck that. So if we do the tile binning, right. So let's just have one of these, just call it like G final color for now. we'll have this many, right? And we'll just access it based on our index. Got float 16 support. Maybe we could use float 16. Not sure where we would. Yeah, maybe that's a good way of doing it. Because doesn't that reduce it on AMD? I did hear that. I'm not sure how they do it though. So we get that final color. So we need an index though, so that's 3 VGPRs instead of well, it depends, it might be calculated twice. No. What are we doing? Have you got a thread index anywhere? Local index. Right, let's flatten this boy out. G final color. Oh wait. So let's try this. So it was on like 60 odd to beat, wasn't it? I forgot the exact number. It was like 0.6 something. What's that doing? Right, so okay, so we'll just call this final color. Let's try that. Right, so that's about the same. It's not taking away added too much to it, I don't think. So let's check the VGPR count. We're on 35 from 38. So that was 3 VGPRs as we thought. So there's 3 more VGPRs to go. And then we should be able to bring it down by 1 section. So any more long-living VGPRs that we can mess around with. So you got the coordinate. You need that for the right at the end, right? You need the full thing, right? So you also need it for the tech. Oh, for the debugging, right? Okay. So what we're going to be doing, do a G, and it should be able to optimize it out, hopefully. So we say G, pixel chord. Now this is only 2 VGPRs. But, so we'll need to save one more. But we'll be using more LDS memory, so we'll see how this goes, right? And then at the end you say pixel chord equal, so that's only for debugging up there. Then you say pixel chord equal, okay. G thread index pixel chord, right? So okay, let's try that out. So that actually increased performance ever so slightly. So how many VGPRs we got? 35. 35 VGPRs? What are you talking about, my friend? How do we increase performance? Yet that's not enabled. Let's try that. Redefinition of chord. Damn it. Oh my days. Let's try that. Right, same speed. Let's run that. Get the stats. Stats say 35 VGPR still. How much LDS we're using? Yeah. I don't know how much higher I want to go, but I could have swore that would have reduced the VGPRs, but I guess. Like, we're compiling the other code out. I don't understand. Maybe it was recomputed from something else. It couldn't have been. Cell position. They wouldn't have recomputed it. I don't know why that didn't give us... It gave us a performance boost though. It's very weird. It's very strange. But yeah, we tried to do the thing where we preload the words in with multiple threads, and it just made it slower. Because we have inactive lanes. That's the problem. We have inactive lanes. So it might be quicker to not do inactive lanes, right? If we move this to where the pixel right is instead, can that make it faster? And can we do the preload? And then we can do the preload. Yeah, but then you have to still wait. Let's take a look at moving this towards the end. If you're outside the tile list, you should never hit that. That's just safety, I think. Right, so the thing is like, well, let's do this at the end instead. Maybe. Do you do stuff with the pixel cord? No. Well, for this you are. Was debugging stuff. We're just not enable the debugging stuff yet. Right, so this runs a bit slower, apparently. We're about the same. It runs about the same. But then I was thinking with that, then you won't have the inactive lane problem, and you can probably use the thread index here to do the preload. We wrote the preload code earlier, but ended up being slower. But yeah, then you'd also have to put a control barrier in and make all the threads wait in the group. And then you'll use more LDS space to preload it into, and it might not be worth it. Right, so I think that's about as good as we're going to get it. We could maybe use F16 support to make it better. Anyway, that's as good as we're going to get it. Sweet. So all in all, we're under an MS, like 1 MS. We could, yeah, for a full screen pass, 2,000 odd draws, which we're not really going to be doing 2,000 odd draws anyway. I was hoping to maybe optimize this guy. So right now, we're doing TEST as separate draw commands, which is just silly because there's so much data. I was thinking about maybe joining them all up together or something. If we enable this one, visualize the commands. So you get a different color for each draw command. If we run this, you'll see that, you know, the TEST are all different draw commands, right? And that's obviously increasing the number of draws way more than it needs to be. So for text, what I think we should do, so for I don't know if it's for monospaced, it only worked for monospace, but I was thinking basically you want to have like a way to say like UI, like UI render push glyphs or whatever, glyphs push, and you just say test, right? Something like that, and you'll get back a glyph start index, or a glyph range, or whatever you want to call it, right? And then your glyph range, so this will just be packed into a 32-bit integer, and you'll just pass in the glyph range here, delete all of this rubbish, and then it's just one command. But I think the issue is in the shader, you can if it's monospace, you can just do a division, and you can land directly into your you can land directly into your glyph. But with different spaced stuff, you might need two lookup tables. But yeah, I think it can still be possible. Don't know anything about Vim scripts. No, I'm not really that good at Vim script. I just copy paste stuff from the internet. I'm not really too good at it, not gonna lie. Yeah. So I think we'll do this optimization next. Because it generally is going to help. And for monospace fonts, it's going to be even better. So I think we might need to stick with monospace fonts, and then this optimization will just be easy. And in the shader, we should be able to reduce all those draw commands down when we just do a bunch of text on the screen, which would be good. Yeah, right. I've got a jam. But I'll next be on Sunday, around 4 p.m. GMT +1, and we'll be doing this, and then we'll be starting up on actually doing some UI stuff. So this will be like the final optimization, and then we'll just be moving on to doing like basically designing the immediate mode UI and how we want to do that. I don't want to do something complex, so we'll try and keep it bare bones, and like I want to keep the system simple. And give a lot of control to the person writing the code, right? But also try and keep the API simple enough. So we'll see how that goes, right? Find it difficult to load C code from Vim plugin, right? Yeah, I'm not really familiar with that. I'm sorry. Did I Jamaica see ya? Thank you for stream. Not so red. Yeah. Have a good night, everyone. Yeah, thank you so much for coming. It's really cool. Like, I'm glad we got this thing optimized to, you know, be good enough. Like, we're not going to be doing 2,000 draw commands, so you know, 1,000 should be fine. Should fly. Right, let's find somebody to raid. There's no one on. C++, whoa. C++ and chill, let's go. Right, have a great start to the weekend, everyone. I'll catch you all on Sunday, where we're going to do some UI library designing. Well, UI API designing. It's going to be pretty sweet. Moving on. Moving on from the rendering. It's going to be good. Right. See you later. Bye-bye.